So, good morning, all of you. In today's class, we'll continue the power of a lens. So, if it comes to the last class, we have discussed what is the rules for obtaining images formed by concave lens, as well as the images formed by concave lens we have discussed. Is it yes or no? All of you. Correct or no? So in last class we have discussed the things and we have solved I think one or two numericals which is related to the lens, and also have taught you what is the lens formula and what is the new Cartesian sign convention for the lens. That is what we have discussed in the last class. So let us come to the today's class. We'll continue from there. So that is only ways to call it as power of a lens. What we should call? So you can keep heading power of a lens. So what is the meaning of this one? What is the meaning of this power of a lens? That is all we'll study now. So let us come to, as we know that we have two kinds of lenses. What is that? Can you able to say anybody?
Convex lens, concave lens.
Convex lens and concave lens. So if it comes to the convex, let me take concave now. So concave, as well as you can come to know convex. So if it comes to the concave lens, we used to call it as diverging. Is it yes or no? Diverging lens. Is it yes? Next, if it comes to the convex lens, which we used to call it as what?
Converging.
Understand? Converging lens means this lens will diverge the light, and this lens will converge the light. Is it yes or no? That is what we have studied. Correct? So that is only called as understanding power of a lens. Means how much the light will be converged or how much the light will be diverged. A parallel beam of light is diverged by a given lens is only called as power of a lens. Means a power of a lens is a measure of the degree of convergence or degree of divergence of light rays which is falling on the lens. Means what if you take suppose concave lens. So how much light is diverging when the light rays falls on it? If you take the convex lens, how much amount of light is converging when it is falls on it? That is only ways to call it as degree of convergence or degree of divergence. That is only we should call it as power of a lens. Do you understanding, Amma? So we have two kinds of lenses. So one is concave lens, another one is convex lens. So one is diverging lens and another one is converging lens. So if it comes to the power of lens means, understand, it is the degree of divergence or convergence. It is the measuring of degree of divergence or convergence. Convergence when light falling on it. Light falling on it. So this is what we used to call as power of a lens. All of you should remember. Write it. Power of a lens. Right. The power of a lens is a measure of the power of a lens is a measure of the degree of convergence or divergence of light rays falling on it. Do you understand it, all of you? Yes or no? Do you understand or not? So all of you tell me, for example, let us take, sir, what is this degree of divergence or degree of convergence means? For example, let us take convex lens. So if we take the convex lens, when a parallel beam of light falls on it, what will happen, right? It will converge at where? A parallel beam of light will falls on it. Please tell me, all of you. A parallel beam of light falls on it, what will happen? What will happen? I'm asking you. A parallel beam of light will take place. Then what will happen? It will converge at the focus. Is it yes or no? Nobody is responding. Nobody will speak also. Then what is the how I will get mood to teach? So when you are inside, when you are falling, when you understand, if you take a convex lens, understand it is what? A converging beam of parallel light rays. So if you are inserting the, understand, so the strong, understand the parallel beam of light more strongly, then it will focusing them closer to the optical center, means on the focus. So we can say that it is said to have greater power. Or if you take another convex lens, which focuses the some parallel rate, understand, greater the distance from the optical center, then we can say a convex lens which is, understand, diverges a parallel beam of light rays more strongly is said to have greater diverging power, understanding, than the another concave lens. So that is what you should understand. So if you take two kinds of lenses, one is convex lens and another one is concave lens. So we can say if it is converging, understand, if we'll insert a beam of parallel light rays, understanding a beam of parallel light rays more strongly by focusing them on closer to the optical center, then we can say it is having a greater power, understand. So that is what you should remember. So for example, what I am saying, observe carefully all of you. So this is the one convex lens, which is suppose example, which is focusing the light rays, understand, at 10 centimeter away from the, understanding, let 10 centimeter away from the optical center. So another lens, again I am inserting a parallel beam of light rays, so which is trying to focus the light rays, understand, away from the optical center. So let us imagine the distance is, understanding. So this is what the away from the focusing. So that the distance is, let me imagine, 20 centimeter. Then who is having more converging power? Which lens is having more
10
converging?
centimeter. Second lens, sir.
Second lens or first lens? What are you talking?
Second lens, sir.
If it is converging closer to the optical center, closer to the optical center, understand, closer to the optical center, then it is having more stronger converging power, understand. So if it is converging far away from it, then it is having less converging power. Now you at least please tell me, so who is having more converging power, who is having less converging power? You can say
10 centimeter, first one, sir.
what I am saying. So converging power, the converging power means what? The amount of convergence, understanding. So the degree of convergence or divergence. So first we are studying convergence, degree of convergence. So if they are converging closer to the optical center, then the converging power is more. If they are converging far away from the optical center, then the degree of convergence is less. Means the power of a lens is less. Do you understanding all of you? So now you observe this one and this one. You tell me who is having more converging power and who is having less converging power.
First one, sir.
First one. Because
First one you have more converging power.
closer
First one has more
to the optical center, so that it is having more converging power compared to the this one, because it is converging the light rays little bit far away from the understanding lens. Do you understanding all of you? Like same way, when it comes to the diverging power, in which case it is more. Suppose if we take a concave lens which diverges a parallel beam of light rays more strongly, it is said to have greater diverging power than another concave lens which diverges the light rays less strong. So that is what you should remember. So the power of a lens depends on its focal length. The power of a lens depends on its focal length. So let us come to the concave lens, diverging power. Suppose you observe very carefully. So here also the same thing. All of you observe. So this is what the power of parallel beam of light rays, if I observe. So in this case, observe all of you. So here, oh, this is the optical center. Let us imagine optical center. This light rays will go straight. So now observe carefully. If it is if it is, we are feeling that it is coming very closer to the optical center, then the diverging power is more. So for example, let us take another lens. Understand? So now let us imagine the parallel beam of light rays. Understand? Which are diverging, which will feel that they are a little bit away from the optical center. Then what is happening? Who is having more diverging power? Who is having more diverging power?
First one, sir.
Can you please teach this again, sir?
Nothing. So the refracted light rays, which will feel that little bit, understanding, closer to the optical center, means it is having more diverging power. If it feels that they are coming far away from the optical center, then they have less diverging power. That's all. Do you understand? Closer to the optical center, more diverging power. Far away from it, then it is having less diverging power. So same way here, if they are converging closer to the optical center, more diverging power. Far away from it, less diverging power. Converging power. Do you understanding, all of you? So if it is away from it, if it is the focal length is moving away from it, understand? If focal length is moving away from it, either concave or convex lens, if focal length is, remember all of you, if focal length is moving away from it, then the power of the lens will decrease or increases. If focal length, understand? Focal length is moving away from it, understanding? Away from the lens, then power will decreases. Do you understanding, all of you? Power will decrease.
Sir.
Either converging power or diverging power, doesn't matter. It will decreases. Understand? So that is why we can say power of a lens is depends on what? Power of a lens is depends on focal length.
Focal length.
That is
Focal length.
So if the focal length is moving away from the lens, then automatically the power of the lens will decreases. Understanding? If the focal length is coming towards the lens, then the power of the lens will increases. Means the sense of, if one will increases, another one will decreases. Means power of the lens is inversely proportional to focal length. That is what you should remember. Understand? Means if the power of the lens is increasing, focal length will decreases. If focal length will increasing, power of the lens will decreases. So that is why we can say the relationship between power and the focal length is equals to, all of you should remember, power P is equals to 1 by F. Do you understanding, Amma? Power P is equals to 1 by F, or else I can say focal length is equals to 1 by P. So these are the two formulas, which is the relationship between focal length and the power of a given lens. All of you, do you understanding or not? Yes or no? So that is what
Yes,
you should remember. Understand? So if the focal length is coming closer to the optical center, then the converging power or diverging power will increases. If the focal length is moving away from the lens, then diverging power or converging power will decreases. I hope you are understanding very well. So that is why from this I can say, understand? So the power of a lens is defined as the reciprocal of its focal length in meters. That is the most important. I am taking, understand, the power of the lens is defined as the reciprocal, means inverse, reciprocal of its focal length in meters. All of you note it down. Reciprocal, power of a lens is defined as the, note it down, power of a lens is defined as the reciprocal of a focal length. Reciprocal means what? Inverse, 1 by. Reciprocal of focal length in what? In meters. All of you should remember. So meters. So nobody should remember, nobody should do mistake that while you are calculating power, always focal length should be in what? In meter. Do you understanding, Amma? Everybody?
Yes, sir.
Yes or no?
Yes.
What you should remember. Nobody should do the mistakes, understanding, at any cost. So that is what. So from this I can write the formula. What you can write the formula? What you can write the formula? If power of the lens equals to Power of a lens equals to power of a
1
lens,
by F.
which is equals to
1 by F.
by focal length. Focal length, but in what? Meter.
Meters. In meters.
Meters. That is what very important one. Understand? So that is what you can remember. So power of a lens is equals to power of lens, understanding, which is equals to 1 by meters. So 1 by meters is equals to dioptries.
Dioptry. 1 dioptry.
Understanding? Dioptries. Dioptries is equals to 1 by meter. Understanding? So that is what you can write it. Or else, understanding, you can write it. Dioptry, we should represent dioptry D equals to 1 by meter. All of you noted down. Units. Is it clear? Any doubt? Anybody? You ask me, please. Pranita, call to Jesse. Recall to friends. So many is absent. Correct. Nitish Kumar is there? Not there. Absent. Call. Pranav is not joined. Dina is not joined. Dina is there. Okay. Dina, call to Pranav. Akil, are you understanding? Akil Arfan. Call to Arya also. Arun Karthikeyan, are you understanding this one? Arya is there. Okay. Arya, do you understand Arya? Power P equals to. Yes, sir. So that is what you should remember. These 4 diagrams also you should draw. Understanding, and you can mention more diverging power, less diverging power. This is here more converging power, here less converging power. No textbook will explain like the diagrams. You have to draw. It is very important for us. So this is what the relationship between power and understanding focal length. Is there any doubt? Anybody? You can ask me, please. Yes or no? So as we know that if focal length increases, power will decrease or increases, sir? Power will increases or decreases? Focal length will increases. Nobody will say.
Decreases.
Decreases. If power increases, focal length decreases. If power will decreases, focal length will increases. So from that I can say.
Jesus.
So from that I can say one point is a lens of short focal length has more understanding power, whereas a lens of long focal length has less power. Write it. A lens of not a lens of short focal length. Okay, Pranita, you carry on. A lens of short focal length. Dina, do you understanding, Dina? A lens of short focal length has more power, whereas a lens of long focal length or more focal length, short or long. Yeah, long you can write. Long focal length. Understanding? Long focal length has less power. So that is what you should remember. Now, Dilipan, you please tell me what is the unit of power? Power is equals to what? Power is equals to what? Power P equals to. Power P is equals to, we know that 1 by F. Means the dioptry is equals to 1 by meter. Means in the sense of
1 by m.
dioptry is equals to 1 by 1 meter. Means in the sense of, if you want to get the power is equals to 1 dioptry, what is the focal length? Dina, what is the focal length? Focal length should be how much? If you want to get the power is equals to, if you need to get, if power is equals to 1 dioptry, plus or minus doesn't matter, then what about the focal length? Then what is the focal length? Then F is equals to how much? That is what I am asking. If you want to get the power is equals to dioptry, then focal length equals to how much? Then F is equals to how much, Ray? 1 meter.
1 meter, sir. 1 meter.
1 meter.
Yes or no? That is. So if the focal length is 1 meter, then the power of the lens is equals to 1 dioptry. Do you understanding, everybody? Yes or no?
Yes, sir.
That is what you should remember. That is the most important. Nitinath, do you understand Nitinath, Karthikeyan, Arun Karthikeyan, Ganapati, everybody. So that is what the statement you should write it. Understand? Right. One dioptry is the power of a lens. One dioptry is the one dioptry is the one dioptry. One dioptry is the power of a lens. Power of a lens whose focal length is how much, Ra? Whose focal length is
1 meter.
whose
1 meter.
focal length, Yalni, are you there? Is 1 meter. That is. All of you note it down. Whose focal length is 1 meter. Is there any doubt? Anybody, Pranav? So that is what you should remember. Is it okay, Ra? Yes or no? Next. So all of you should remember. As we know that, understanding. Now itself I am saying you, please kindly remember, because nobody should get confused in this. So that is why I am saying you directly now here. For two formulas, power of a lens. Now just now you have studied. Tarni Pushpa, can you able to say what is the power of a lens? Power of a lens P is equals to 1 by F. Is it yes or no? Yes, but you people please don't get confused with this. Understanding. So now itself I am saying you listen. The formula will little bit modify for concave lens and as well as convex lens. Let us come to the convex lens. All of you should remember convex lens, and the next one, another one is what? Concave lens.
Concave lens.
Concave and convex lens. So as we know that, first one, sir, always focal length they will give in centimeters. Is it yes or no? 90% cases focal length will give in centimeters, correct?
Yes, sir.
Will give in centimeters. Is it right or wrong? Here also F will give.
Sir.
F will give. Understand? In centimeters. So people by the time you no need to go for conversion. Directly we can use this formula also if you are very convenient. Always you remember F of convex lens is what? Positive or negative? Focal length is positive or negative? Convex lens.
Positive, sir.
Positive.
Positive. Here F is equals to positive or negative?
Negative.
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 You should remember always. So here in this case, then power of a lens is equals to 1 by F positive only. But in this case, what will happen while you are substituting? 1 by minus F should come.
Minus.
By minus F should come while you are substituting the concave lens. So here, that is why power of the lens is equals to plus dioptries will come. Understanding? So here, power of the lens will come what? Minus
dioptry.
So whenever you are getting, suppose example I am saying plus power of the lens is plus 2D, means in the sense of it is which lens, Ra? Convex lens. Convex lens. Understand? If suppose example power of a lens is P is equals to minus 2D. Do you understanding, Ra? Dina? It is Arya. This is concave lens. Do you understanding, all of you? That is what you should remember. Okay, da? Now,
Yes, sir.
all of you, do you have any doubt? You can ask me, please, kindly. Do you have any doubt, Akil Arfan, Arya, Ashika?
By calculating focal length, you told that the power should be meters of sir.
That is what you wait. Focal length will, that is always you should. Focal length, whenever you remember, when they have given, when focal length is, understanding, note, this also keep it noted down. When focal length is given in centimeter, understanding, we must convert into what? Centimeter, must convert it into
Meters.
must convert it into meters. Understanding, Ra? Meters. That is what you should remember. So for example, as we know that 1 meter equals how many centimeters, Ra? 100 centimeters. Same way, 1 centimeter equals how many meters? Please tell me, all of you.
1 by 100.
100
1 by 100 centimeters.
1 by 100 meters. Understanding? That is what you should remember.
1 by 100 meters.
Yeah, 1 centimeter equals to 1 by 100 meters. Suppose they have given 20 centimeters, then how many meters? 20 divided by 100 meters. Do you understanding, all of you?
0.5, sir.
100 meters. Any doubt in this? Anybody, please ask me. 20 divided by 100 meters. Is it yes or no? All of you? Yes or no? So, that is what you should remember. 0.2 meters is Kevin is saying. Or else you can see. Sir, when they have given focal length is understanding in centimeters, then you can write the power formula like this. Power p is equals to, if f is equals to centimeters, remember power p is equals to, directly I can write 100 divided by f. Will you able to accept it, please? All of you tell me, will you able to accept it? How many of you will say that? Accept it or not? When they have given power, focal length is centimeters, directly you can write, understanding, 100 divided by focal length. Will you accept it? Then no need to convert a focal length. Will you accept it?
Yes, sir.
Do you understanding how it will come? Anybody, any doubt, ask me. So usually, as we know that, understanding, if focal length is given in centimeters, I can use this formula directly. P is equals to 100 by f. Remember, if f is equals to given meters, then you can use normal formula. P is equals to 1 by f. Do you understanding, Ra? So this is the two formulas. Now I am categorizing. Understanding? P is equals to 100 by f. When they have given focal length is centimeters, directly you can go with it. If f is equals to meters they have given, then p is equals to 1 by f. Directly you can go ahead. So you can tell me, because you may observe here focal length, when they have given centimeters, what will happen? 1 centimeter is equals to 1 by 100 meters. Is it yes or no? Is it yes or no? So now what is happening? So 1 by 100. So that what will happen? It will go up 100 by 1. Is it yes or no? Nobody will
Yes,
answer.
sir.
That is the
Yes,
reason.
sir.
Okay, da? So now I am teaching you two formulas. When they have given focal length is centimeters, what we should do? We have to use
P is 100 by f.
by p is equals to 100 by focal length. Understanding? So when it will become positive? When they have given convex lens, p is equals to positive. When they have given concave lens, p is equals to
Negative.
p is equals to
Negative.
that is what is note it down. If f is equals to, if f focal length is given in centimeters, if focal length is given in centimeters, then p is equals to 100 by f. Note it down, all of you. Power of a lens is equals to 100 by focal length. Here no need to convert again into meters. Remember, if focal length is given in meters, then power of a lens is equals to 1 by focal length. Do you understanding, all of you? Yes or no?
Yes, sir.
So that is what you should
Yes,
remember.
sir.
It must be centimeters. Here it must be meters. No textbook will say it, but few times, why I am saying you this one? We have a benefit of this. Can you able to say, anybody? Why I am saying this? Because you may observe carefully, 99%,
Check whether our answer is
even though when we know the concept, while we are substituting it, because in a hurry, exam tension, we people will forget to convert it into meters. Is it yes or no? If you are using a single formula, correct or not?
Yes, sir.
Yes, that is the
Yes,
reason. Suppose if you are reading the question, while you are reading the question, if it is centimeter, then directly we can go with 100 by f. If it is meters itself, focal length is given in meters itself, we can directly will go with 1 by f. That's all. So by that time, if you will convert or not, doesn't matter. Directly you are doing correctly only. So no worry. Do you understanding? Pranav? So that is the reason. Understand? So somebody please to Nitish Kumar. That is what the formulas you should remember, all of you. So when we are using the understanding power of a lens, means focal length is in centimeter, you can use the formula 100 by focal length. When we are using understanding power of a lens in meters, focal length is in meters, then power of a lens equals to 1 by focal length. If you want the examples also regarding this, shall we start with 2 examples?
Yes, sir.
Then it is understanding, right? It is better.
Yes, sir.
Examples you can write, right? If, right, all of you. Example, if a convex lens of focal length is 10 centimeter, a convex lens of focal length is 10 centimeter, what is its power? What is its power? If convex lens of focal length is 10 centimeter, what is its power? What is
Sir,
its
plus 10 dioptry.
power?
Plus 10 sir.
Given, so which formula will use? Given you observe. So focal length is given in centimeter. So what we have to do, Ra? So you usually we people
Equal to
do
100 by
100
F
by
formula,
F.
sir.
normal method. So normal method first. Normal method, what we will do? Given focal length is equals to 10 centimeter. 10 means plus 10 because of why? Convex lens. Correct?
Convex length.
Focal length is 10 centimeter, means in the sense of 10 by 100 meters, which is equals to 0.1 meter. Is it yes or no? Is it yes or no? Which is equals to, people will say that 1 by 0.1. So here also people will do mistake. 1 by 0.1 means something you will write, which is equals to 10 dioptries. Is it yes or no, ma? Is it yes or no? So that is what the general normal method. Now you see what we will use. Understanding shortcut. So shortcut method. So what is the formula when they have given centimeters? What is the formula?
100 by
Understand, it is concave lens, convex lens. So it is plus. So 100 divided by 10 centimeter plus 10 centimeter. So that's all. Which is equals to what? Which is equals to what?
dioptries.
Which is equals to 10 dioptries. Do you understanding all of you? That's all.
Yes, sir.
Okay, na? Yes or no? So that,
Yes, sir.
but this is the formula which you have to use only for what? When we are using power of a lens, is given in
Centimeter.
centimeters. By the time 100 will come. That is what the thing you should remember. Okay, na? All of you? That is. So directly we'll get the answer. Okay? Now, write the next question. If the power, if the, right, if the focal length of a, if the focal length of a given concave lens is 1.2 meters, find its power. Find the power of a lens. Find the power. So what we should do here? You may observe here. Given what lens? Concave lens. So as we know that F is equals to what?
0.8 D.
Meters. Directly they have given.
Minus
Lens is given meters. So power of a lens is equals to 1 by minus 1.2 meter. Equals how much? Minus 10 by 12 ray. 10 by 12 meters. How much it is? 0. Minus 0.8. 9 also will come, correct? Okay. So minus 0.8.
Sir, 8, sir.
Minus 0.8. Understand? Do it. Minus 0.8 dioptries. That's all. So here they have given directly meters so that we no need to convert anything. Do you understand or not?
Yes, sir.
That is what. Note it down. All of you do it fast. Do you understand or not now?
Yes, sir.
Solve it. So this is about the power of a lens. So if you have any doubt, anybody you can ask me. Understand? So if you understand this, then we'll go for the last concept that is only called as power of a combination of lenses. All of you keep reading. Power of a combination of lenses. Power of a combination of lenses. Power of a combination. Combination means what, Ra? Just join. Do you understand, Ra? Yes or no?
Yes.
So that is what. So if it comes to here, what is the meaning of this power of a combination of lenses means? Remember, understand, if a number of lenses are placed in close contact, then the power of a combination of lenses is equal to the algebraic sum of individual lenses. That is only called as power of combination of lens. So if you keep one concave lens and one convex lens together, then their total power is equals to sum of the algebraic sum of the power of individual lenses. So that is only we to called as power of combination of lenses. Understand? So for example, so let us consider understanding. So one of the lenses, understand, one of the lenses P1, power of a lens, understanding. One lens is P1 and another lens is P2. Then what is the power of combination of lens? Power P is equals to P1 plus P2.
P1 plus P2.
So P1 plus P2. So this is what we used to call as power of a combination of lenses. So let the individual power is P1 and individual P2 power is P2. Then if you combine these two, then power of a combination of lenses P is equals to P1 plus P2. So this is only called as power of combination of lenses. So let us consider, we have two kinds of lenses. One is convex lens. So let us consider this power is plus 6D. Understand? Another one is concave lens. So let us consider its power is minus 2D. Now, what is the power of accommodation? What is the combination power? Understanding? Power of combination. What is the power of combination? Power of combination means I will combine these two lenses like this. All of you observe carefully. I will combine these two lenses like this. This is what? Plus 6D. And this is what?
minus 2D.
So what is the power of the lens formula? Combination. Power P is equals to, let me imagine, P1.
6D.
This is
4
the
dioptries.
and this is the P2, which is equal to, understanding. So P1
Plus
plus
6D
P2,
minus
which is
2D.
equals to plus 6D and
Plus 6D plus
minus 2D,
minus 2D.
which is equals to 6D plus into minus 2D,
minus 2D.
which is equals to plus 4D.
4
Is
plus 4
power of a combination. Understand? So power of combination of a lens is equals to power of combination. Power of combination of lens P is equals to plus 4D. Do you understanding, all of you? This is
Yes,
what
sir.
is called as power of combination of lenses. So all of you draw these diagrams and you write the definition first, right? Right, all of you. Definition. If a number of lenses are placed in close contact, if a number of lenses are placed in close contact, then the power of the combination of lenses is equal to the